1982, 1997, 2015. Three of the strongest El Niños ever recorded, and right now the Pacific is trying to do it again for a fourth time. Here's 26. If the difference between a 97 style winter and a 2015 style winter changes how you plan your operation, this video tells you which one you're actually getting. I teased the comparison as short. You asked for the full breakdown, so here it is. Here's the problem. If you only look at the surface, all four of these events look pretty much identical. Boom. That's just in the Equatorial Pacific. There's a second layer, if you will, invisible on a standard map, that decides how each one actually delivers its impacts and where. 5 signals separates each of these events. And there's one more wild card that doesn't match any historical years at all. I'm going to walk you through all of it today in this video, side by side with the real numbers. Let's start with a raw ONI, the Oceanic Niño Index. This is the 3-month running average of sea surface temperature anomalies in the Niño 3.4 region of the Central Pacific. That's a mouthful. It's the core metric though. A value above plus 5 degrees Celsius defines El Niño conditions. So here's where we stand. Boom, right there. The latest published ONI. That's the official 3-month running mean from NOAA's CPC. For April, May, June, that came in at plus 0.98 degrees, just shy of a full degree, and climbing fast. Now overlay that on the 3 historical events. In absolute terms, the trajectory of 2026 tracks close to where 2015-16 was at the same point in the calendar. But there's a second way to look at it. Not where the number sits, but how fast it is moving. Look at the month-over-month change. From March to April, 2026 gained roughly 0.4 of a degree. From April to May, another 0.5. Now go back to 1997. The exact same 2 months, March to April and April to May. They gained almost the identical amount, 0.4 then 0.5. That's not a loose comparison. That's close matches you're going to find in that kind of rate of warming. Now look at 2015, however. Over that same 2-month stretch, the gain was about 0.2 each month, meaning roughly half the speed. 2015-16 got strong eventually, obviously, but it built more slowly. So here's the honest complexity up front on where the number currently sits. This looks like 15-16, okay? On how fast it's climbing to get there, this looks like 97-98. Both of those things are true at the same time, and that's exactly why the surface comparison isn't enough. You need the background state to break the tie. The model consensus for the December, January, February peak is projecting somewhere in the range, give or take 2.5 to 3.5 degrees. There's some outliers there too, which puts it in the same tier as all 3 historical analogs. And if you don't want to just take the ocean surface's word for it, we shouldn't, there's a second independent way to check it. What's happening below the surface? This is the subsurface ocean heat content in the Equatorial Pacific, essentially the reservoir of warm water that feeds the surface warming. Think of it as the fuel tank, if you will, behind the number you just saw. At the same point on the calendar, in June, 1982-83 was sitting at plus 1.01 degrees. 2015-16 was at plus 1.51. 97-98 was at plus 2.25. And 2026 right now, guess what? Plus 2.25. That's not close. That's identical. The surface rate and the subsurface reservoir are telling you that the same thing at the same time. And if you look at the spatial fingerprint, the actual pattern of warm and cool water across the Equatorial Pacific only, the resemblance across all 4 events is pretty striking. We have the warm signal in the East Pacific and a slightly cooler signal in the West Pacific. The geometry looks nearly identical at first glance, but nearly identical is doing some work in that sentence, and that's exactly what the next section will unpack. Oh, but wait, when you look at the entire Pacific Basin, it's not even close. It's much warmer than the past 3 big events right now. Not every strong El Niño warms the Pacific in the same place. Some events are eastern based. The warmest water just sits right up against South America. That's what's called the Niño 1.2 region. And we call that an EP event for Eastern Pacific. Other events are more centrally based. The warmest water sits farther out, kind of toward the international date line. And that would be in the Niño 4 region. Those get called CP events, or sometimes you'll hear Madoki, which kind of tries to identify the different configurations of where the warmest anomalies are. This matters because an eastern-based event and a central-based event don't deliver the same impacts to North America in the same way. The storm track response and the moisture sources are different. 1997 to 98 was about as textbook an eastern-based event as you'll find. The Eastern Pacific was warming roughly 4 times faster than the Central Pacific at the same point in the year. 1982 and 83 was kind of similar, heavily eastern-based, even more lopsided than 1997 to 98 once it got going, though that one didn't develop until a few months later in the year. So it's not quite the same side-by-side comparison. 2015 to 16 was different. It warmed almost as much in the Central Pacific as it did in the East. Still a very strong event, but a much more mixed, centrally kind of weighted signature, if you will. So where does 2026 sit? Right now, the Eastern Pacific is warming close to twice as fast as the Central Pacific. That's more eastern-leaning than 2015 and 16 was at the same stage, but it's not the extreme eastern dominance that defined 97. It sits in between. I want to be straight with you about what that means. 2026 doesn't clearly match either side of the comparison. It's not a clean 2015-16 match, and it's not a clean 97 match either. Keep that in mind as we go through the rest of the background states in this video, because on every other signal, this event does lean one direction very clearly. But hang on to that thought, because later in this video, there's a signal that does something even more different. The one we're focused on now splits the difference, right? Well, the one we're about to discuss shortly, it doesn't match any of the 3 historical years at all. Let's move to the background states properly, starting with the PDO, the Pacific Decadal Oscillation. In one sentence, it's basically a long cycle pattern in the North Pacific sea surface temperatures that can amplify or dampen El Niño's impacts on North America, particularly the western U.S. and Southwest. A positive PDO, that's warm water in the central and eastern North Pacific, tends to amplify the El Niño teleconnection. The storm tracks are more active. The subtropical jet reaches farther inland. A negative PDO runs the opposite direction. It's a background dampener. Now look at the historical comparison. During the 1997 to 98 event, the PDO was strongly positive. The 2 signals were in phase. El Niño's subtropical jet was running full strength with no headwind. The result was one of the most dramatic single-season precipitation responses in the western U.S. on record. During the 1982 to 83 event, the PDO was also in positive territory at the event's peak. And during 2015-16, the PDO was positive there too. Not as strongly positive as 97-98, but clearly positive straight through the December, January, February peak. It's easy to remember 15-16 as the one where the Southwest recovery fell short, and some may assume a negative PDO was why. But at the actual peak of the event, the data does not back that up because it was a positive PDO moment. So here's the real picture. All 3 of the strongest El Niños on record, 1982, 97, and 15, happened with a positive PDO in the background. Every one of them had that amplifier working in the same direction as the El Niño signal, not working against it. And today, the PDO is currently in a strongly negative phase. That's not a match to 2015 and 16. It's not a match to any one of the 3. This is the first data point in this video where 2026 doesn't have a clean historical twin. Not 1997, not 1982, not 2015 and 16 either. None of the 3 biggest El Niños on record peaked with a negative PDO working against them. What it means in practical terms is the El Niño signal right now, it's real. It's building, but the PDO backdrop is actively working against it in a way none of the other 3 historical comparisons had to deal with, which means the downstream impacts, particularly for the Southwest or Central Plains, could end up more moderated than any of the 3 historical events would suggest. Quick heads up on where this is going. I'm not going to force this into a clean matches 2015-16 story just because that's the comparison I opened with. I'd rather give you the honest, kind of messier picture than to force a tidy little answer. Stick with me. The verdict at the very end will have a cleaner perspective than what history does anyway. Background state number 2, the RONI. This one is less familiar, so let me spend just a quick moment on it because it matters. The RONI stands for relative ONI. The standard ONI measures sea surface temperatures against a 30-year running average that's updated every 5 years. The RONI takes that one step further. It measures each El Niño's intensity relative to the background state of the global climate system at the time it occurred. Why does that matter? Because the total ocean is much warmer today than it was in 1982. So the baseline has shifted. The RONI corrects for that. When you apply the RONI correction, you can actually watch the baseline shift underneath these events in real time. 1982-1983 ranks highest on the adjusted scale. 97-98 comes in just below it. 15-16, the most recent of the three, and arguably strongest by raw ONI, comes in lower still. That's a step down across all three events in order as that baseline climbs. In plain English, the more recent the event, the more warming trend eats into its relative ranking, even when the raw number looks just as extreme or more so than it did 40 years ago. Now, I want to be careful about how I frame this because it can be misread or misheard. A RONI adjustment does not mean the impacts are smaller. The Pacific is warmer overall, which means atmospheric moisture is higher, atmospheric rivers carry more water, and precipitation extremes can still be very significant. What the RONI is telling you is that the relative departure from background, that anomaly itself, is not as extreme relative to the era of, say, 1982 or 1997 too. For our purposes, if that 40-year trend holds, a 2026 event peaking at a similar raw ONI to the three historical events would likely rank lower still because of that adjusted scale. We won't have that actual number until this one peaks, so take that as just a direction, not a verdict at this moment. And another example of how this event may be measured against the others. This is not to say, again, that the impacts will be smaller. Background state number 3, the QBO, quasi-biennial oscillation. This is the least familiar of the three, so let me be precise. The QBO is an oscillation that happens in stratospheric wind direction over the tropics, so give it 15-30 miles above the surface. It cycles between westerly and easterly phases on basically a 28-month cycle or so. And it turns out which phase that QBO is in during an El Niño matters for how the tropical heating signal connects through the atmosphere and where the precipitation and temperature impacts concentrate. Here's the current situation. The QBO has been in a negative easterly phase, and it is transitioning to a positive westerly phase. That means by the time this El Niño peaks, somewhere in October through January, we will be in a westerly QBO. Now look at the historical events, and this is where it gets more interesting than a clean split. The 2015-16 El Niño admittedly was during a period when the QBO didn't behave as expected, but the event peaked during a westerly QBO. But so did 82 and 83. 97 to 98 is a genuinely odd one out of all of them. Its peak fell almost exactly when the QBO flipped. The stratospheric wind was swinging from westerly to easterly right as the event peaked. So here's the honest read. QBO doesn't actually separate 15-16 from 82-83. Both were westerly. Same direction. Same direction 2026 is heading. What it does do is add real uncertainty around 1997 to 98, which is a different, more useful piece of information than a clean 3 for 3 would have given. Regardless of exactly which historical years land on which side, the mechanism still matters. These are composite maps of El Niño winters stratified by that QBO phase. The left panel is the El Niño years with the westerly QBO. The right is El Niño years with an easterly QBO. The patterns are not identical. The westerly QBO tends to produce a stronger subtropical jet that connects and modifies how the temperature and precipitation signals distribute across North America. The 2026 event, heading into a westerly QBO, aligns with the left panel, not the right. Now I'll be honest about the limitation here. The number of strong El Niño events we have to sample is very small. Splitting them even further by QBO phase means we're working with a very limited historical record. What the QBO gives us is a kind of a directional modifier, not a precise forecast. But directional modifiers matter when you're making seasonal decisions, and ignoring them means you're implicitly using the wrong composite. 2 more signals worth knowing about faster than the last 3. One of them turns out to be the cleanest historical match in this entire video. The other doesn't match anything. First, the AMO, the Atlantic Multi-Decadal Oscillation. It's the Atlantic's version of the PDO, a slow cycling pattern in North Atlantic sea surface temperatures that runs on multi-decadal rhythms. It doesn't drive El Niño per se, but a warm phase AMO tends to run alongside wetter, more active patterns for the eastern half of the U.S. 1982 to 83 sat in a neutral to cool AMO. 97-98 was right at the hinge point, just flipping into the warm phase. 2015-16 was fully into a strong warm AMO, and 2026 is also in a strong warm AMO right now. No ambiguity, no in between, If you're searching for the single strongest data point in this whole video connecting 2026 to 15, this is it. Second, the IOD, the Indian Ocean Dipole. This is the wild card I mentioned at the start, so let me flag it as one important thing instead of just folding it into the table. The IOD is the temperature seesaw between the western and eastern Indian Ocean, and when it runs positive at the same time as an El Niño event, the two tend to reinforce each other. It's part of why 97-98 produced such extreme flooding in East Africa, drought in Indonesia. All three historical events, 82, 97, 15, they were flat to positive in the IOD at the same point in the year. 2026, though, right now is negative. It's been declining since spring. Now, the IOD really doesn't lock in until later in the year, maybe like August through November. So this is not a final read on this yet. But it is worth watching because if it stays negative or even neutral, that's one less amplifier working in the same direction as the historical events. Let me put all of this on one table. On where the warming is centered, Eastern versus Central Pacific, 2026 sits between 97's strongly Eastern signature and 1516's more mixed one. Call that one, I guess, a tie, leaning slightly Eastern. No historical match really in either direction. On the PDO, 82-83 was positive, 97-98 was strongly positive, and 2015-16 was positive too. All three of the strongest El Niños on record happened with the PDO amplifying that signal, not dampening it. 2026 is strongly negative right now. That's not a match to 15-16. That's not a match to any of the three. On the RONI, the adjusted ranking has been stepping down across all three events. In order, 82-83 highest, 97-98 next, 15-16 lower still. We can't score 2026 yet. This event hasn't even peaked. But if the trend holds, expect it to rank lower again, kind of like 2023. On the QBO, 2026 is heading into a westerly phase. Same as both 82-83 and 15-16. 1997-98 caught the QBO almost exactly at a 0-point crossing. It's when it flipped. So it's genuinely ambiguous rather than a clean opposite. On the AMO, 82-83 was cool. 97-98 was barely warm. 15-16 and 2026 for that matter are both strongly warm. So here's the honest tally of the five signals. Exactly one. The AMO cleanly and specifically points to 2015-16. The PDO points away from all three historical events. The QBO groups 2026 with two of the three. The RONI is directional but unscored until this event peaks. That's not the clean verdict I expected when I started this video. 2026 is not a repeat of 15-16 any more than it's a repeat of 97 or 1982. It's its own combination. And the piece that stands out the most, perhaps, is the PDO, because none of the three strongest El Niños on record peaked with a negative PDO working against them. If that holds through winter, we're looking at a background configuration for a major El Niño that doesn't have a clean precedent in this comparison at all, no historical basis. Here's what that means and how you should be thinking about this winter. All three historical events, 82-83, 97-98, and 15-16, have the PDO helping the El Niño signal, not fighting against it. 2026, if the current pattern holds, would be the first of the four to have that amplifier working against it, kind of like 2023 did. If 2026 goes into its peak with a negative PDO working against a similar El Niño signal to the other threes we've been chatting about, that's a real headwind. So when someone asks me, is this going to be as big as 1997? My honest answer is, well, on the background state evidence, not the same shape of impact, even if the raw ONI number gets there. The rate the ONI is climbing, yeah, it matches 97. AMO matches 2015-16. PDO doesn't match anything in this comparison. And for the Southwest specifically, that's the signal I'd weigh the most weight on, because it's the one place where 2026 is doing something none of the three historical analogs did. Now let's take that one step further, because this is part that actually matters for planning. Say the PDO stays strongly negative right through winter, and the QBO fully locks into its positive westerly phase. That's not a hypothetical. That's the most likely path based on where both indices sit right now. So I want to be straight with you about this part. That specific combination, negative PDO paired with positive QBO, doesn't have a clean twin among 1982-83, 97-98, or 2015-16. So what follows is mechanistic reasoning, not a historical composite. What that combination tends to produce, a real functioning subtropical jet connection because of a westerly QBO, that supports that. It supports that link regardless of what the PDO is doing. but a ceiling on how far that moisture pushes into the southwest and how completely it can recover that deep drought and the reservoir deficits there, because a negative PDO works against the eastern Pacific storm track reaching in that far. That's still a significant event. That's still a winter worth planning around carefully. But it's not a 1997, and it's not a 2015-16 either. It's genuinely its own thing. And to be honest, a version of that story is more useful to you than a tidy it's basically 15-16 would have been. Two things I'd ask you to do if this was useful. First, let me know in the comments whether you see this level of background state analysis pretty nerdy. If you like that applied to a specific region, let me know. If your operation needs this kind of multi-driver analysis built around a specific location or specific decision, consulting link is in the description. I'll see you for the next one.